In this video, we're going to continue some discussion about the time value of money. In this case, though, we're going to switch to talk about other kinds of cash flows. The first type we'll talk about are annuities. An annuity is simply an equal cash flow payments over a certain period of times. Now, they can be either inflows or outflows, but they happen over a specified period of time. Now, there is a difference, two different types of annuities. In a previous video, I talked a little bit about the concept of when cash flows happen. Financial calculators and Excel assume that cash flows occur at the end of the period. However, in reality, investments typically happen at the beginning of the period. So when you read a problem or when you're discussing an issue, we have to be sure we recognize when the cash flows occur. So an ordinary annuity is an annuity when the cash flow occurs at the end of each period. An annuity due means that it occurs at the beginning of each period. So in the problem, it's going to have to state that. So it'll say something like, we're going to start investing and we're going to start investing today. That tells us the way. Since it starts today, that's an annuity due. Now, in the Excel sense, there's a type, and that type is either a 0 for an ordinary annuity, or it's a 1 if it's an annuity due. The formulas, if you're using actually the formulas, you have to recognize that, and there's an adjustment to the formulas. And likewise, on a financial calculator, you're going to have to tell it whether it's at an ending or beginning. You'll have to review the process of how to do that on a financial calculator. But why this is important, think about investing, right? So you're going to invest $1,000 over 5 years. Now you can start to invest today. Here's an annuity due. So you invest $1,000, 1, 2, 3, 4, over 5 years. Or you can wait till the end of this year. At the end of year 1, you put 1,000, and 2, and 3, and 4. And then at the end of the 5th year, you would invest $1,000. So the question here is, what's the difference between these two cash flow streams? Well, if you look at the middle, all of these are the same. So their growth is always going to be the same. What's going to be different is this cash flow that you make today is going to grow 5 times. This cash flow that you make at the end of the 5th year doesn't grow at all. So an annuity due will grow to a larger amount than an ordinary annuity. So when you're investing, we always think about investing today. Now, to make our calculations and our exploration, if you will, of time value a little simpler, except for very specific instances, we're going to always assume it's an ordinary annuity. So here's how we calculate the formula. And as what you'll see is it gets to be a pretty complicated formula. Again, all the variables are the same in the math, but down below here, we have the Excel formula. It is just the future value formula, but now you're going to have a payment. Now, when does that payment happen? If you put a 0, 0, that's an ordinary annuity. If you make the type, 1, then it's going to calculate it as an annuity due. So here's an example. We want to save some money. We're going to invest $2,000 a year at the end of each year for 10 years. Compounded annually, we can earn 12%. So now we're going to start to incorporate down here the payments. So the payment that you're going to make, we're investing $2,000, so it's a negative $2,000. 12% is the interest, time is 10. Of course, you have to remember to to delete all of these. Now this says, is this an ordinary annuity, Y or N? Well, you also need to know if it's an ordinary annuity, it's a yes, or the answer would be it's a 0. If it's a annuity due, it would ultimately be a no, obviously, or it would be a 1. So the value, the future value of this annuity then would be $35,097. So think, what's 12% of $2,000? 240. 240 times 12, or excuse me, by 10 is $2,400. How did that end up being $35,000? Again, think about this. $2,000 grows annually. Every time you make the investment, that $2,000 grows for the remainder of the lifetime. So let's think about a retirement example. Let's assume you want to invest $5,000 at the end of each year into an IRA. You can earn 10%. You expect to retire in 40 years. How much do you think will be there at the end of retirement? Again, plug this in. The answer is in the notes of the PowerPoint for this particular presentation. I also might suggest plug this information in for what your current retirement plan is. How much do you invest? But I would put it in as a monthly basis because you're probably making monthly deposits into your 401k through your paychecks. So I would do it monthly and see where you would be if you can earn 10% on your money. When you plan on retirement, how much money do you think you'll have? Now, if we do a future value of annuity due, again, the key word to look for is the beginning of the year. Again, our equation changes, or the type in our Excel formula goes from a 0 to a 1. So if we do the exact same problem, except go from the beginning, what you'll see is there'll be a big difference in the return, the dollar value at the end of 40 years if you start today versus if you wait till the end of the year. Now, the present value annuity is a very similar process, right? Again, we have the mathematical formula here. We have the Excel formula. Again, remember, ordinary annuity, the type equals 0. That will help us. This basically says, look, if you're going to get cash, let's say you want to, in retirement, you would like to get, let's just say $50,000 a year in retirement. All right, that is, every year you get that, that is an equal amount for a certain number of years. In order to invest so that you can receive that money during retirement, how much money do you have to invest? So this is kind of a calculation for what you think your nest egg might be or would need to be to provide you with a certain retirement income. So here, this company is thinking about an investment that's going to pay the company $35,000 a year at the end of the year for the next 10 years. And this has a low risk investment, so it's only going to need to earn 4.79%. So what is the value in today's dollars? Again, interest rates 4.79, time in years is 10. Now we're going to receive 35,000. So you now see this number is now positive. That gives us $273,038 is the current value of this particular investment. Again, here's our retirement example we talked about earlier. But notice in this case, I kind of changed the scenario, right? You're going to get $25,000 per month for retirement for a total of 30 years, and you can earn 8% on your money. How much money do you have to save between now and retirement, right? What is the nest egg that you need the day you retire so that you can receive this funding? And again, you have to remember that M is going to be 12 because this asks you for monthly payments. And just as we did a second ago, we talked about the present value of an annuity due, the exact same thing. In Excel, it's much easier because you just need to change the type from 0 to 1, but it's a little bit of a more complicated formula for the present value of an annuity due. Again, so in this example, you're going to get $125,000 a year for 30 years if you can earn 8% during retirement. Again, how much do you need to invest at retirement to receive this cash flow stream? Again, just as I've mentioned before, the notes are in the solutions are in the notes. Check that out. And again, you may have some question about your own. Later on in another video, we'll talk about some particular problems that we can solve, one of which is a retirement thing. So we'll actually go through this and show you how to do a little bit of a retirement analysis. And of course, you can always plug in your own numbers to see what you think about your current retirement plan. Now, one of the things that we do have to be concerned about is growth. I mean, think about retirement. If you retire when you're 65, how long do you think you'll live? Right? I mean, it's kind of a sticky question, I guess, right? But think about your family. On average, how long do people live? Right? In my family, 85 seems to be about the length of time for our family. So, I know that when I retire, I'm just going to forecast. I think I can live till be 90. So I know that if I retire when I'm 70, I've got 20 years for that to receive those cash flows. And the last year, those cash flows aren't going to buy as much as they're going to buy the first year. So I want to incorporate some growth into the payments. The growth I might want to put in here is, let's put in inflation. So if you're looking at the formulas, there's no formula in Excel to do this. So we have to do this actually by hand. But there is a formula to find the present value using growth, present value of annuity, assuming some growth. Here's our formula, and this is the one for future value. Again, the math gets a little ugly, so you have to check, make sure you do the proper calculations for the math. Now, in the actual worksheet that I have for you, I've placed those formulas in there. So again, if you want to receive $125,000 at the beginning of each year for 30 years, and you'd like your payments increased by 3%, and you can earn 8% during retirement, how much do you need to invest? So down here, we have a cell, the growth of an annuity. This is where you would put that 3%. And again, you can calculate and find that value on your own. We can also do the same thing with the future value of growth. You're going to start investing $500 a month. You're going to retire in 40 years. You think that annually you're going to get a 4% increase in salary. So now you want to adjust your investment in your 401k accordingly. Take your bonus, assume that's going to go into your savings. You can earn 12% in your money. how much will be there when you get to retirement. There is one special kind of form of an annuity. This is called a perpetuity. And a perpetuity simply is the present value of an annuity, but the annuity has an infinite life. It has a very simple formula. It's just cash flow divided by the interest rate per year. Now, an example of this for a growing perpetuity is what we refer to as this is actually a stock valuation growth model. We'll use that a little bit later, but of course this spreadsheet will also do this for us because the formula is embedded in the spreadsheet. So here we're talking about an endowed chair. $200,000 a year is what it's going to take to endow this chair, and they can earn about 10% per year on their investment. How much do we have to invest in order to pay out $200,000 a year? And the second question is, what if inflation is 3%? We want to keep up with inflation. So again, we put 10% in the interest rate. We don't need to know time because this is an infinite time frame. We're going to receive $200,000. And there's a growth of 3%. So if you don't assume inflation, it's going to take $2 million to do this. Now, if you think this is kind of simple, right? What's 10% of $2 million? 10% of $2 million is $200,000. So this is like an interest-only payment. As long as the university here can earn 10%, every year will be able to pay out the $200,000. With the growth of an annuity, though, perpetuity, inflation, we're actually going to have to invest $2.9 million. So again, this is just a special example, if you will, of a special type of an annuity called a perpetuity. So again, I hope discussion here of these annuities was interesting for you. I look forward to seeing you the next time.